In lesson 3.2, we're going to look at solving systems of equations algebraically. In 3.1, we solve by graphing, which sometimes can be an estimation process because you have to estimate the point of intersection if there is a solution. With substitution and elimination, which we'll review here, you've been taught these before, then we get exact solutions. So when we do them algebraically, that does give us an exact. So sometimes it's a little bit better than solving them graphically. Two methods, substitution and elimination, that we'll look at. We'll do substitution here first. And when you are told to use substitution on a quiz or a test, you must know substitution. When you are told to use elimination, you must know elimination. If I say solve the system with the method of your choice, you can use either one. So make sure you know both methods. But substitution, one equation is solved for a variable in terms of the other. If it doesn't start out that way, you have to get one of the equations solved for one of the variables. Then that expression is substituted in for the variable in the other equation. So let's say you solve one of the equations for y and you get 2x plus 4. Then in for y in the other equation, you would substitute 2x plus 4. And we'll do that for this example down here. But again, it's asking me to use substitution. So if I give you this problem on a quiz or on a test, you must use substitution. So you can't just know one of the methods, and we'll review elimination here in a little bit. So what you want to do is you want to solve one of the equations for a variable. And it does not have to be y. It can be, but you can solve for y or x. So I'm going to pick, we've got two equations here. I'm going to pick the first equation, and I notice that the x has a 1 in front of it, so I'm going to solve the first equation for x. Okay, I would try and find one that's got a coefficient of 1 or negative 1, because then you don't end up with messy fractions and things like that, and it makes things a lot easier. So if I solve this for x, to get x alone, I would subtract 4y. So that would be gone. So x would be 26 minus 4y. And we can write the constant term first. It doesn't really matter. You could have written it negative 4y plus 26. But now what you're going to do is you're going to take what x is equal to. It's an expression, 26 minus 4y, and it goes in to the other equation for x. Now, that x over there has a 1 in front of it, so there's not going to be a number we have to distribute. But for instance, if that said 2x minus 5y equals negative 10, you'd have to put 2, and then in parentheses, the 26 minus 4y. And then the 2 would have to be distributed when you go through and solve for y. So just be careful with that. I don't have an example like that. But so you'd put that in and you'd have 26 minus 4y. If that x had a coefficient in front of it, you'd have to put it inside parentheses. Here, it's just a positive 1x. Even if it was negative x, you'd have to put the negative sign out in front of x, and then out in front, and then 26 minus 4y in parentheses. But that goes in for x. Then I have my minus 5y. After it equals negative 10, which is the rest of the equation here. So there's what we have, 26 minus 4y minus 5y equals negative 10. So once you do that substitution step, you've developed an equation that only has one variable in it. You can solve for that one variable, in this case y. We are going to combine these two terms. They are on the left side, so we're going to put them together. So it's 26 minus 9y, negative 4y minus 5y is negative 9y, is equal to negative 10. Now I'm going to subtract 26 to make it 0 on this side. I'm going to subtract 26, so negative 9y equals, this would be negative 36. And then I'm going to divide by negative 9 in my next step. Negative divided by negative is positive. So I have found y is equal to 4. Okay, or that y is 4. Now you have to go back and plug this in to one of your original two equations for y and then find x. I'm going to choose the second equation, x minus 5y is equal to negative 10. It does not matter which equation you go back and put 4 in for y, but I'm choosing the second one. So here's what I'd have. X minus 5 multiplied by 4 is equal to negative 10. Which would be x minus 20. X minus 20 is equal to negative 10, and then I would add 20 to get rid of it. So x would be 10. You can write your answer in a couple different ways. You could say x equals 10, y equals 4, but it's probably best, and when you check answers, they're going to have them written as an ordered pair. So remember, that's x comma y, so it would be 10 comma 4. So make sure you put the x first. Like I said, it doesn't really matter if you write it as an ordered pair or this. Just realize when you're checking answers, they're going to have them written as ordered pairs. So that's substitution. Elimination is the second method. And I'll give you some time to get this, what I have in red, down, or pause the video here. And let's actually move this down here. Here's what you need with elimination. You need opposite coefficients in front of either x or y, and if it's not x and y, whatever your variables are, to eliminate one of the variables. All corresponding terms must be lined up, including the equal signs. What I'm talking about there is from the separate equations in columns. Sometimes, and actually many times, you will have to multiply one or both equations by something to get the opposite coefficients you need in front of either x or y. Now, what do I mean by opposite coefficients? Like 5 and negative 5, 10 and negative 10. Okay, they have to be opposite signs in front of the x terms or the y terms on the two different equations. And we'll do a few examples here. Now, the book, or what they go through, they say you'll do it by adding or subtracting. The way we teach it, when you get opposite coefficients, because I see way too many mistakes with subtracting, I don't ever do that. When you do adding, you have to have opposite coefficients. So when I do adding, because that's going to eliminate and cause them to be 0, x, or y, whichever variable you're talking about. So I always add, okay? Opposite coefficients, and then add meaning combine like terms. So what you want to do here, when we're using elimination, here's what we have. I'm going to rewrite these. You want everything lined up. So what I mean is, you need this to be the case. My x terms lined up, my y terms lined up, my equal signs lined up, my constants lined up. Everything has to be lined up in order for you to do elimination. And it is here. Now, we need opposite coefficients in front of either x or y. It does not matter which one you pick. So I'm actually going to multiply on this. As you can see in front of x here, if you look at in front of x, right now I have a 1 and a 1. They are the same coefficient. We want opposite coefficients. So what I'm going to do is I'm going to multiply the second equation by negative 1. Why do I choose negative 1? Because that's going to give me negative 1x there. I'm going to leave the first equation as is. So x plus 2y is equal to 10. This would be negative 1x or negative x then. And you got to distribute the negative 1 to all terms. So negative y. And then don't forget the constant on the other side. So this needs to be multiplied by every single term on both sides of the equation. Okay? Now you draw your line, everything in column form. And once you have this part right here is 0x. It drops out. It eliminates. So the x's eliminate. And I get positive 2y and negative 1y, which is y, is equal to a 10 and a negative 6. Just think of them combining like terms. A 10 and a negative 6, or 10 plus negative 6, is 4. Now, many times you don't end up with 1 in front of your variable there, and you'd have one extra step here of dividing. But in this case, we have a 1 in front. So y is equal to 4. We have just found y. Now you go back to one of the two equations. I'm going to go to x plus y is equal to 6. The second one, we put 4 in for y, so I really have x plus 4 is equal to 6. Well, to solve that, I subtract 4, so x is equal to 2. Now, you could give both. Make sure you specify which is which, but I think it's best to write in an ordered pair, which the solutions manual is going to do, and it would be 2 comma 4, x first, y second. So if you graph these two lines just to tie it into lesson 3.1, they would intersect at 2 comma 4. Okay, another elimination example here. So let's line everything up. So 2x plus 3y is equal to 12. 5x minus 2y is equal to 11. Okay, let's take a look at what we're starting with. Notice we've got everything lined up like we talked about. The x's, the y's, the equal signs, and then the constants of 12 and 11 this time. So what you want to do is you want to look at this. Sometimes, like the one I just did, I just multiplied one of the equations by something. To check for that, if you look at your x terms, look at what's in front of them, a 2 and a 5. Does 2 go, ask yourself, does 2 go into 5? It doesn't, evenly. Say, okay, well, let's see if y, I could just multiply one of them by something. And you have a 2 and a 3. Ignore the signs, just look at the numbers. 2 does not go into 3. So you're not going to be able to multiply just one of the equations by something. This tells me I have to multiply both of them by some number. Different numbers, but some number. Okay, so what I do then is pick a variable to eliminate. Oh, let's say I'm going to eliminate y's. Okay, I'm choosing to eliminate y's. Doesn't really matter. We're going to have to multiply both equations by something. So I want to look at the two numbers I have. I have a 3 and I have a 2. I know it's negative 2, but just say a 3 and a 2. Ignore the signs for a second. Okay, what you want to do is you want to find the smallest number that they go, well, you want to find a number that they go into. A lot of times it works out to be the smallest number. Sometimes it's the two numbers multiplied together. In this case, it would be 6. So I want one of these to be 6 and the other to be negative 6. This is kind of what I'm looking for right here. Now, if I notice, if I look at these terms right now, you see how you have the top one is already a positive and the bottom one is already a negative? So I'm going to make the top one positive 6y, and I want to make the bottom one negative. Now, how does that help me determine what I multiply by? If you notice, I've got, right now, a positive 3y. So positive 3y, and I want to make it a positive 6y. So positive 3 times what is 6? Well, that would be 2. That tells me I have to multiply my whole top equation by 2. On the bottom, I have negative 2y, and I want to make it negative 6y. Well, negative 2 times a positive 3 will equal negative 6. So now, you're going to multiply the whole equation. 2 times 2x would be 4x. So I have 4x plus 6y is equal to, don't forget to multiply your constant by whatever you're multiplying the equation by, which would be 24. Down here, I'm going to have 15x, because I'm multiplying the 3 times the 5x. I already did the 3 times the negative 2y, but now 3 times 11 is 33. Notice I've gotten opposite coefficients in front of the variable I chose to eliminate, which in this case is y. So now you do elimination. You add in columns, okay, because everything's lined up. These eliminate, that's 0y. These are both positive, so that's 19x. 24 and 33 combined is 57. So I have 19x equals 57. How would I solve that for x? I divide by 19. 57 divided by 19 is 3. I've just found x. So now you're going to have to go plug that back into one of your original two equations. I'm going to choose the 2x plus 3y equals 12. Always go back to one of your original two. I mean, you could go to after you multiply, but the numbers are bigger, so it's probably easier just to go back to one of the original two. And I'm going to put 3 in for x, so it's 2 times 3 plus 3y is equal to 12. So 6 plus 3y is equal to 12. I'm going to subtract 6. So 3y is equal to 6. I'm going to divide by 3. So y is equal to 2. So I tie these two together as an ordered pair. 3, comma 2. The x is 3, the y is 2. Now, we're going to look at an inconsistent system. If you remember from 3.1, an inconsistent system would be, if you graphed it, ones that have parallel lines. Okay, now we're not graphing it, but when we're using this process of either substitution or elimination, what causes it to be inconsistent? So let's look at what we have here. Let's write down the equations as we have them. We have 6x minus 10y equals negative 21. So I can't eliminate to start with because I don't have opposite coefficients of the same number, okay? But if I notice on my x's right here, I have negative 3x and 6x. So what I'm going to do is I'm going to multiply this top one by 2 because 3 goes into 6 twice. And I don't have to multiply the second equation by anything. So that's going to give me negative 6x, I'll come over here and do it, plus 10y is equal to 24. Again, we're taking 2 times everything, both sides of the equation. I don't have to multiply the second equation by anything, so I'm just going to rewrite that. Got to have everything lined up here, like that. Now, look at what happens. I was choosing to eliminate x. I multiplied by 2 to get the negative 6x, okay, so that these right here eliminate. But look at what happens to the y's. They eliminate also, which means I have a 0 on this side. So if both variables eliminate when you do this, let's go ahead and combine these. A 24 and a negative 21 combined is 3. If you do that and you get 0 is equal to some other number, okay, the 0 on the side where both variables eliminated, that is not true. That's false. 0 is not equal to 3. If that's the case, it is a no solution answer, okay, or the empty set. If you went through and put these in slope-intercept form and graphed them, they would be parallel lines. But this is how you determine it when you're using one of the algebraic methods of substitution or elimination. If you go through and solve and both variables drop out and you get a false statement, which we got right here, it's a no solution answer. Inconsistent system. Just a side note on that, if you go back, sorry about that, but if we go back right here, if you eliminate a variable and the right hand side, if these right here, if you would have gotten 0 is equal to 0, in other words, let's say this would have been 24 equals, or 24 and a negative 24, where you would have got 0 on both sides, then it is infinite number of solutions. You would say an infinite number of solutions. So if you get a true statement, and I don't have an example of that in the notes here, but if you get a true statement, it's an infinite number of solutions. If you get different numbers, 0 is equal to 3, for instance, okay, but then that would be a no solution. But if you get 0 on the other side, which means you'd have opposites over here of the same number. So if these were like 24 and negative 24, which would cause this to be a 0 here, 0 is equal to 0, it would be an infinite number of solutions. And that may occur as you're working on your problems.